have a big sheet of paper. Now, if I ask you to fold it once, you can do that. If I ask you to fold it twice, you can do that too. But what happens if you keep folding the paper again and again? Each time you fold, the paper becomes thicker and thicker. Let's see what really happens when we fold a paper. At the start, the thickness is just 0.001 centimeter, almost invisible. After one fold it doubles, then doubles again with each fold. So 0.001 becomes 0.002, then 0.004, then 0.008, and so on. Notice the pattern? Each fold multiplies the thickness by 2. It grows extremely fast. By 10 folds, the paper is already over 1 centimeter thick. By 17 folds, it's taller than most of us. At 26 folds, it reaches the height of the Burj Khalifa. And at 30 folds, it's about 10 kilometers, the height where airplanes fly. This kind of rapid growth is called exponential growth. Now, let us carefully see what is happening mathematically when we fold the paper. At the start, 0.001 centimeter. After one fold, 0.001 times 2 equals 0.002. After two folds, 0.001 times 2 equals 0.004. After three folds, 0.001 times 2 equals 0.008. After four folds, 0.001 times 2 equals 0.016. Notice how the number 2 is being multiplied again and again. Writing 2 times 2 again and again is very lengthy. So, instead of writing it many times, we have a shorter way. When we multiply the same number again and again, we use a power or an exponent. We read this as 2 squared or 2 to the power 2. We read this as 2 cubed or 2 to the power 3. We read this as 2 to the power 4. So instead of writing 2 many times, we write 2 with a small number above it. The small number tells us how many times we are multiplying. For example, 5 times 5 times 5 times 5 equals 5 raised to the power 4 is equal to 625. Here, 5 is called the base, and 4 is called the exponent. Let us see what happens with positive and negative numbers. Example 1 4 times 4 equals 64. We can write this as 4 superscript 3. Since the base 4 is positive, the answer is positive. Example 2. -4 times -4 times -4. Let us calculate step by step. First, -4 times -4 is equal to plus 16. Then, 16 times -4 is equal to -64. So, -4 superscript 3 is equal to -64. Rules are, if the base is negative and the exponent is even, the result is positive. If the base is negative and the exponent is odd, the result is negative. The same idea works with letters. This is read as a cube times b squared. This is read as a squared times b to the power 4. We can also use exponents to write large numbers in a simpler form. Example 3600. Step 1. Break it into prime factors. 3600 is equal to 2 times 2 times 2 times 2 times 3 times 3 times 5 times 5. Step 2. Group them 2 raised to power 4 times 3 raised to power 2 times 5 raised to power 2. So, 3600 is equal to 2 raised to power 4 times 3 raised to power 2 times 5 raised to power 2. Try another 32400. Step 1. 32,400 is equal to 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3 times 5 times 5. Step 2. Group them 2 raised to power 4 times 3 raised to power 4 times 5 raised to power 2. So, 32,400 is equal to 2 raised to power 4 times 3 raised to power 4 times 5 raised to power 2. Moving on, let's use a story to understand repeated multiplication in a bit more detail. there are 3 daughters. Each daughter has 3 baskets. So total is equal to 3 times 3 equals 9 baskets. Each basket has 3 keys, and each key opens 3 rooms. So 9 times 3 is equal to 81 rooms. Each room has 3 tables. So 81 times 3 equals 243 tables. Each table has 3 necklaces. So 243 times 3 equals 729 necklaces. Each necklace has 3 diamonds. So 729 times 3 equals 2187 diamonds. So the total diamonds is equal to 3 times 3 times 3 times 3 times 3 times 3 times 3 is equal to 3 raised to power 7 is equal to 2187. This story explains to us the use of repeated multiplication and the use of powers. Now let's study the rules of exponents. Rule number 1. Multiplication with same base. If the bases are same, the power add. P raised to the power a times p raised to the power b is equal to p raised to the power a plus b. Example, p raised to the power 4 times p raised to the power 6 is equal to p raised to the power 10. Rule 2. Multiplication with different bases but same power. If the powers are same, then the bases multiply. M raised to the power a times n raised to the power a is equal to m times n raised to the power a. Example, 2 raised to the power 4 times 3 raised to the power 4 is equal to 2 times 3 raised to the power 4 is equal to 6 raised to the power 4. Rule 3. Division rule. This is same as multiplication. M raised to the power a divided by n raised to the power a is equal to m divided by n raised to the power a. Let's discuss another story to understand the rules in detail. In a magical pond, one lotus doubles every day. And in another pond, if we place one lotus in a pond, the number triples every day. If we first keep the lotus in the doubling pond for 4 days, we get 1 times 2 times 2 times 2 times 2 is equal to 2 raised to the power 4 is equal to 16 lotuses. Then, if we move these to the tripling pond for 4 more days, 16 times 3 times 3 times 3 times 3 is equal to 16 times 3 raised to the power 4 is equal to 2 raised to the power 4 times 3 raised to the power 4 is equal to 1296 lotuses. If we reverse the order, first 4 days in tripling pond, then 3 times 3 times 3 times 3 equals 81, then 4 days in doubling pond, we have 81 times 2 times 2 times 2 is equal to 1296 lotuses. The result is still the same. This shows that the order does not matter. So today, we learned how repeated multiplication leads to the idea of powers or exponents, how they help us express large numbers, and how they grow very fast in real-life situations like folding paper or flowers spreading in a pond. We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 8. Thank you.